So for today it's a review, but I want to start with the thing we did yesterday. So what we did yesterday is we took 1 over all the y values. That was called finding the what? Reciprocal. If I made an xy chart and I put 2 comma 100 on it, and I put 3 comma 1/10, after you do the reciprocal, this 100 would change, wouldn't it? And it goes from a very big number to a very small number. And a very small number would change to a big number. 10 isn't that big. I should have made it 1/100th. But the point is that when you have a normal number like 1, you put 1 over 1, it doesn't even change. But where your function gets really big, the other reciprocal will get very small. All right, let's do it. I know it's asking about the intervals, and we will do that. But you know what? Let's do that first, because otherwise we're going to draw all over this, and it's going to get messy. So we'll start with the intervals. Increasing intervals. Well, it looks like it's increasing in here. Let's agree that that starts at -2, just because it's kind of vague. It's not really clear, but we'll say that it starts at -2. What do you mean? It's at -4, Mr. Server. That's not how you judge it. You start with the x values. Okay, so the increasing interval starts with -2 to what? Lillian Miller. -2 to what? It's like you're putting bars here and there. So, 2. -2 to 2. Is there another interval, Mariam? Yep. From? Yep. 4 to infinity. Okay, and put a u in between the two, because it's that and that. Or another way you could say it is or, actually. You could say it's increasing here or there. And it's kind of better said and, so I don't really like, yeah. Anyway, it's definitely not an intersect. That wouldn't make any sense. They don't intersect, so. All right, decreasing intervals, that's pretty easy. It's from 2 to 4. Is that the only decreasing interval? No, there's another place. From where? -infinity to -2. Okay, this place is special. It's not only the local minimum, it's the absolute minimum. Okay, how about this spot? Local maximum. Is it the absolute max? No. And that spot? Local min. Not anything else, just the local min. Okay, and is there any absolute max? No, because it goes up forever, so there's no max. All right, next, let's actually do a quick reciprocal of this. So everybody, assume this is f of x, then I want to know what would the reciprocal of that look like. Drew, tell me one of the key things you look for.
Where the line crosses over
1 and -1. Excellent. So there and there and there and there and there. Those are all spots where it had a y value of 1 or -1. Oh, and tell me another spot you look for on these, because you got to make asymptotes there.
Those spots where it touches 0.
Where it touches 0. So there's an asymptote there. There's an asymptote there. And there's an asymptote there. Okay. What if there's an area that you're kind of confused about? Like, I'm not really confused about this area. It just goes up and it goes back down this way, because it's, you know, you got to follow the asymptotes and it goes through that one spot. But what if I was confused about an area, like let's say in this zone here? What if I told you to do, if you're confused about how to draw it in that area? Yes.
Get specific points.
Get specific points. Like, for example, this looks to me like it goes through -2, -4. and which one changes as we do the reciprocal. The y value. So it goes from -2, -4 to -2, -1/4. So way up here. And now I've got 3 dots I can use to judge this. This and this, because those are spots where it was -1, and that. And now I can get much better. So you can always make more points. All right. Where did I say you would see most kids get it wrong? Yes. Ends. Let's do this end. Now, I kind of have a tilted asymptote line there because I was trying to make it go through -3. I'm going to straighten that out a little bit. But the asymptote is to the right of this spot. Okay. Now I'm going to have to go up this way because it has to not, I can't go down because the Great Wall is down there. You know, the x-axis, you can't go across it. And I look and see there's an arrow here, so that means I can just make an arrow there. What happens if there's not an arrow? Let's say there was a solid dot right here. Then you'd need to know what is that solid dot. Let's say you thought that it was at -3.5, 3. I know it's not perfect, but let's say that it was that. Well, then you would just find an ending point. So if it's a solid dot like this, you would just make another solid dot on yours right here at -3.5, 1/3. And you would have stopped. If this was solid, you would have to stop. Okay, so let's look over here. It's got an arrow. That means I can just get closer, and I can just go like that. Arrows allow other arrows. All right, here's one where there is not an arrow in a very critical spot. So try to be careful to not do anything wrong here. Use the process. Got kind of a Halloween theme going here. Good luck. I'm going to pause for a second and give this a try. All right, did you start by putting a dot at 1, which is here and here and here and there? Then at -1, here, 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 and here. Then asymptotes, dotted lines that go through where the blue function is touching 0. Now, I could totally see somebody just doing the ends like this and going, but doop, what did I just do wrong? It's got to be a dot. Drew, explain how I do a dot on the left-hand side here.
You found the point on the very end of the line.
What did you decide this was? Because we'll let you decide that.
I decided -7, 3.
Okay. So then what are you going for as the other point, the counterpoint I was calling them?
-7, 1/3.
-7, 1/3, which is like here-ish. And notice it stops then, right there. And this has to be straight underneath that and stopped, not an arrow. Okay, good. Now let's finish this thing off. If I wasn't feeling confident about this, I would have figured out exactly what point is this, and I would have made a counterpoint right there, thank you. And here, oh, I could totally see a kid doing this. What's wrong with that? What's wrong with the U?
That interval right there is all white.
Those are all 1s. They all have y = 1. So then when you flip 1, you get 1 and 1 and 1 and 1. It just stays the same across there. That is weird, but if you're not sure, you make points, and you'd say, yeah, they all have a y value of 1, so they'll all stay the same. All right, last one's this. Let's say I'm not sure. I'm going to label this as 3, -2. Then it would lead me to believe I should graph 3, -1/2, which is right about there. And then I use this and that, and now I really have a good dialed in where to go. Okay, any questions about sketching reciprocals? Okay, good. Then how about absolute values? This is my original. You don't know what the function is. My gut says it was x to the third, but then they flipped it, so negative x to the third, and then I think they moved it up 4, plus 4. Can you believe that that's possibly what they did?
They moved it to the right.
Oh, they also moved it right one. I agree. So then I'd put in here a -1. I think you're right. Okay, so it doesn't matter. We wouldn't test you on that. I'm just showing you these can be functions, or they can just be weird little sketches that they make. Now, do you know what the difference between this and this is? Nick V, can you explain what we do on either one of those two? You pick.
When the absolute value's on the outside,
Okay, then what are you going to do to the graph?
I think you bring all the negative x's up.
So all of those aren't there anymore because you can't have negative x's, so they all become positive, and then it goes up. So your answer is both negative y's, sorry. Yep, and I didn't draw that terribly well, I'm aware of that. But the original graph plus that-ish, sort of. Too much curve. Anyway. All right. Any questions about that? Okay. Then how about the kind over here where you absolute value the inside? Well, I explained that very thoroughly the other day, but if you didn't catch that, here's the simpler version. You take all the x's that are negative and they can't be the same anymore, so we erase them. And then you reflect the right side over to the left side. So it looks something like that. If you're putting in a -1, the idea is that the function, the first thing it'll do is it'll take your -1 and absolute value it, and it'll act just like you put in a regular one, and it'll therefore repeat the same answer it gave for regular one. That's why it does what it does. All right, I made it a little too wide. It's bothering me. I'm going to try to make that better. Because, like, for example, it's about 2.5, so it should go through about there. That's better. Okay. Any questions about absolute valuing things? All right, there's more. In fact, here's a lot of things. Critical identification from a graph. For that, I'm just going to say we talked about local mins, local maxes, intervals that are increasing, intervals that are decreasing. The y-intercepts, the x-intercepts. X-intercepts are where y equals 0. Y-intercepts are where x equals 0. Solutions to f of x equals 3. Let's talk about that for a second. Everybody sketch this. It's going to be a little weird. And I'm going to say that that height that happened at was, let's say, 5. Let's say right here is 6. Right here is -4. So here's my question. Can you tell me the x-intercept? Don't overthink it. Can you tell me the y-intercept? Can you tell me f of 0? Can you tell me f of x is 5? Try to answer those 4 questions about my little sketch. Let's have it just keep going this way. The x-intercept of it, the y-intercept of it. F of 0. And f of x equals 5. I'll pause for a second while you try to figure out those 4 answers, and I'll ask you to compare them with the kid sitting next to you, so do your best pausing. All right, here we go. Hopefully, you knew that the x-intercept is that spot, so then therefore -4, 0. The x-intercept is where y is 0, so -4, 0. And the y-intercept is where 0, 6, because the x is 0. And then f of 0 is Well, that's where x is 0. It's the same exact thing. I was just seeing if you understood that. And then you could just say 6. I would have been fine with that too. Just 6 would have been perfectly good. And last but not least, f of x equals 5. I hope you knew that that was a line that went through all of these spots. So technically the answers were here and not there, but there.
Oh, that dot was good. That dot was.
I told you.
I didn't.
They were supposed to all be lined up, and I get they weren't perfect, but so there's an empty spot that it doesn't touch, and then this spot and this spot. So there are 2 answers, 2 solutions to that question. And I didn't ever say exactly what these were. If this was like 7, then it would have been 7 comma 5. And if this was like -2, then it would have been -2 comma 5. Okay, let's move on. These are a bunch of review questions that I strongly recommend that you do. And I'm going to give you a bunch of time. And then if you're stuck on any of them, like, where's quadrant 1? You can come up and ask me. But the one I would like to do together with you, and by the way, when I say you should do them, the reason I think you should do them is there's an answer key. So go look at the answer key when you're done, or even if you're stuck in the middle of it and you're like, I don't know how to do this one, go look at the key, but then note it for yourself to make sure that you study that. If you don't know how to do it today and the test is tomorrow, you know, note for yourself which are your weaknesses. All right, but let's do this one. I think it's probably even because it has an x squared in it. But that is not a guarantee just because it has an x squared in it that it's even. Do you remember how to do this? Everybody do it with me. You put -x in the function. And then you put it in the function here too. And then you simplify it. F of -x is, well, that -x that's getting squared will just go away. And I gave you a very easy one here. And if you stopped right there and didn't say anything more, it would be wrong. Because the whole point is to tell me if it's even or odd, or and how do you know? So here's how you have to finish. Pay attention. You have to finish with one of the 2 proof statements. Either this equals f of x, or it equals -f of x. Well, this one, is this really f of x? Yeah, look. It came out the same as it was in the first place. So yeah, it's f of x. And therefore, this thing was even. If you don't finish with the proof statement, you can't have credit for this one. Just like last time you had to prove something, you had to prove f of g of x equal g of f of x. You had to write that. All right, so let's do another one, except, do you know the rule for odd? F of -x will equal?
-f of x.
Yes, but I'm changing it to -1 f of x, and here is why. I wouldn't mark it wrong if you said -f of x, but you need to be able to get that a -1 will factor out of your function. Here's what I mean. Let's say you had 3x squared plus 2. Everybody, just humor me. Stick -x into that. See what happens. And wait, I screwed up. It's to the 3rd. Sorry, it's to the 3rd. You're right.
The thing inside.
You're right. I'll fix that. It actually won't change the answer in this case, but you're right. So I'll fix it.
In the squared case.
Gotta be careful. Yep, you're right. So now you stuck -x in, right? And here's why it's better to think of that as being a -1 in that little proof statement. Because you'll have -3x to the 3rd plus 2. Do you get how a lot of kids think? They've just proved that it's odd because they go, look, there's a negative and then there's f of x. But there's supposed to be a negative in both parts of it. So you factor out a -1 and see if you get f of x. Everybody factor out a -1. I know I'm stretching your abilities here because you may not even remember how to factor out a -1. But if you divide everything by -1, that's really what you're doing. You'd get 3x to the third minus 2. See, that's what you'd need to get f of -x is equal to -1 times f of x. But did I just lie? Is this really f of x? That is not f of x. So then you would say it's not equal to, and therefore it is not odd. And you would have thought this was odd, because look, it's got a to the third power in it. But it's not odd? Nope. If you actually look at the graph of it, because you move it up to the graph of it, you'd see it's no longer got the right kind of symmetry. Here's where it was, and it has origin symmetry. But then you move it up 3, and it doesn't have origin symmetry anymore. See what I mean? That's why it's not odd. So here's the key. Got to factor out a -1. And then if you do that and you get f of x here, the only thing that was wrong, that was supposed to be a plus. See? So it's not equal to that, so it's not odd. All right. There's the hardest thing besides reciprocals is these proofs. That means you'd be really dumb not to practice these tonight. All right. We have about 15 minutes left, and now the rest of the time is yours to study using this key that's posted and this set of practice problems. And there is a Dropbox for it. It is all assigned, not having to skip any of them. Yes?
Oh, it's a specific.
Okay, then I am done with the video for today.